Okay, so now, here we go. There's a really famous equation. Do you know who came up with this equation?
I think Einstein? Euler?
There's a third famous mathematician whose name begins with E. We got
Euclid?
Einstein, Euler, and Euclid, right? Euler came up with this equation. This is called Euler's equation. It has the 5 most famous numbers in math. I'm not going to explain why this equation is true. I'm just showing it to you because it's kind of neat.
Okay.
E to the pi I plus 1 equals 0. So it has the 5 most famous numbers in math. E, pi, I, 1, and 0.
My favorite number.
Yay! Super awesome equation, right? But we can rearrange this equation. This is the same thing as saying e to the pi I equals minus 1, right?
Yeah.
Yeah.
Okay. Now these two things are equal, so if what we've learned in math is true, if we do the same thing to both sides of the equation, it still should be equal.
Yeah.
Is that right? I'm going to take the square root of both sides. The square root of e to the pi I, whatever that is, should be equal to the square root of minus 1.
Which equals I.
Does anyone know what the square root of minus 1 is?
I.
3, 2, 1.
I.
You do?
Yeah.
Okay, say I if you know what it is.
I.
Okay, so this is I. Now remember I said the square roots were the 1/2 power?
Yeah.
Okay, so this is the same thing as e to the pi I to the 1/2. And it just multiplies in, right? Pi I divided by 2. Okay? So this is e to the pi I over 2. Sorry, let me write that a little better. E to the pi I over 2. Okay? Equals I. So that's interesting. Now, but we were trying to figure out what I to the I was, right?
Yeah.
Okay? Well, what if I just raise everything now to the I-th power?
Yeah.
Okay? So I've got e to the pi I over 2 to the I-th power. What's going to happen to that?
It's pi times I squared.
Okay? And this is I to the I on this side. Hey, that's what we're trying to find.
But
Yeah.
this I squared is minus 1.
Okay? So this, when I multiply the power, I get a minus 1 times pi over 2, right?
Yeah.
So this is e to the minus pi over 2 equals I to the I.
E to the minus pi over 2. That's a weird number.
E to the minus pi over 2. Now, what's really weird about this? When you look at this equation, what is surprising to you about this?
These two natural numbers can add up to be a complex number.
Okay, so yeah, we got to be careful about the phrase natural number, which you didn't mean that has a meaning in math. These are real numbers.
Yeah, real numbers can be.
E is a real number. It's about 2.71828.
Yeah.
Pi is a real number.
3.14.
3.14-ish.
9, 2, 6,
Minus 1 is a real number. 1/2 is a real number. This side's all real numbers. This side
Is imaginary.
is an imaginary number to an imaginary power. It gets you back to a real number.
What?
What?
That's sort of weird.
I to the I is e to the minus pi over 2. Everyone put their pondering face on. How could that be true?
I think I know.
You do?
Yeah, I think it's because of the infinite decimals after.
Well, there's no decimals anywhere though.
But pi and e both have decimals.
That they do when you write them out. Yeah. So this is one strange fact. Pondered. Okay. And now your number is just a tiny bit more complicated to understand. It was pi to the e to the I.
Yeah.
Okay. So once we understand this, we could understand this, but there's one extra thing in math you have to know. So I'm just going to skip that for now.
Yep.
But remember, I said this was about, when we calculated it out on Wolfram Alpha, this was about 1 plus 3i over 2.
Okay.
It's very close to that. Very close to it. So this is about equal to that. Pi to the e to the I. It's a pretty cool number. You're the first person I've ever run across whose favorite number was pi to the e to the I. Pretty good favorite number, right?
Yep.
All right. Triple high five. Okay, and everyone who knows this, say aye.
Aye.
All right, good job, guys.